in my videos, it's very difficult for me to film equipment installations, right? So in this situation, in this video, we're doing an installation on a walk-in cooler. And what we're doing is replacing the condensing unit and the evaporator. For those that have watched a lot of the videos, this is replacing an evaporator that kept icing up. I was a follow-up visit from another company. I went behind them. They were having issues, and I found that they had installed the evaporator fan blades on backwards. So therefore, they weren't moving the airflow through the coil at the correct CFMs, basically, and the coil was icing up. Okay, so anyways, this is that video. We're replacing that evaporator in the walk-in cooler. The walk-in freezer will be coming soon. Again, I digress. So in this one, though, I usually don't film installations because I usually have several of my employees there, and I've chosen to not include my employees on my YouTube videos, okay, for a lot of different reasons. But so it's always difficult. So I tried to film them, and I actually have a lot of footage from a lot of installations, but it just never adds up, and it's just never the kind of footage that I want to release as a normal video. But as I was watching this one, there was some really cool little nuggets and different things that I thought were important. The whole point of these videos is to share the little bit of knowledge that I have, and also to share the mistakes that I have made over my career. And so I figured, you know what, this was a good one, okay? So when I get to the recovery, right, and you guys are going to see what I'm talking about, I turn on the recovery machine, right, and it's the MR45 field piece recovery machine. I turn it on, and it makes a funny noise. And then it shuts off. And I'm like, what the heck? Okay, it happened once. I really didn't think anything of it. I pushed the button again, and I started it up again. And this time, an error message came across the front of the recovery machine. All right, the recovery machine caught a problem before it burnt up the motor. All right, and you guys will see. What actually happened was I plugged into a bad receptacle. Now, the second time I pushed it and it shut off again, I tested the receptacle, and I had 120 volts from line 1 to neutral. Okay, I'm assuming we probably had a loose neutral or something was funky in there. I really didn't dig any further into it. And then I ended up plugging into a good receptacle, and the recovery went through smooth. You guys will see it. So just pay attention. On the second time that I hit the button on the recovery machine, you guys are going to see an error message pop up on the recovery machine that says throttle. And what it's telling you, the recovery machine's going a little haywire, basically, because it thinks that the pump is being overloaded, and it's telling you to throttle the inlet pressure because maybe it was getting too much liquid or something and it was causing an overload situation. But that's not actually the case. In this situation, we had an electrical fault. But still, the cool thing is that inside the field piece pump, they have a built-in safety that will prevent you from burning up the motor. I thought that was really cool. So let's get on with the video, and you guys will see what I'm talking about. We are going to get started on a recovery today. I've got a walk-in cooler condensing unit, and on this condensing unit, I am able to hook up to actual king valve and suction service valve with no Schrader parts. So that makes it easier and makes it smoother and faster, essentially, for the recovery process. Obviously, when we're doing a recovery, the most important thing is to have open flow throughout all the hoses. So if you notice, I'm using the field piece S-Man 480V. Okay, I'm using bigger process hoses. That's a 3/8 process hose coming out of the machine, a 3/8 hose going directly into the tank. Now, what I'm doing is this is actually loose right here, so I can go ahead and open this up, and open this up, and I'm going to purge. There we go. I purged the entire system all the way through the tank. Okay, we are hooked up to the liquid port. Tighten it on, make sure it's nice and snug. I happen to be using the field piece scale, and what I'm going to do is go ahead and zero the weight right now. Okay, and we're going to go ahead and open up completely because I'm removing everything, all the refrigerant from this system. So we're going to open up for full flow. Open up my process all the way. Okay, and we're going to go ahead and open this guy up. The scale is already zeroed out right here. And we're going to go ahead and start pushing refrigerant into here. Okay, so what we're going to do to save wear and tear on the machine, it really wouldn't hurt the machine anyways, but to save wear and tear and make it go faster, we are going to let all the refrigerant push into that tank as much as possible. That was a vacuum down refrigerant cylinder. Okay, now I have the scale on there so that way we don't overfill the tank. Okay, you got to be very careful. I am recovering R22 refrigerant, and I know that the charge in this is nowhere near the capacity of that tank, but I'm still gonna watch it. All right, so at this point, audibly, I've heard all the refrigerant move through. Okay, we're in the recovery mode right here, and we're gonna go ahead and hit start. Really interesting thing, and you guys are gonna hear it right now, is this machine ramps up. It has a DC motor that does a slow ramp up. And by doing the slow ramp up, you're able to pull less inrush current, basically. Unlike other machines, there's no requirement for extension cord size. So you can actually use a 16 gauge cord if you needed to, because it has a slow inrush on startup. So we're gonna hit start and you'll hear it. Fully open, fully open. I think I might be plugged into a bad receptacle. The machine is running and you heard that slow ramp up, okay? And we're just gonna let the process go. Now, the field piece recovery machine actually has an automatic shut off. So once it gets down to -10, at the end of -10, it's gonna do the first shut off, and then it automatically turns off, and then you can push the start button again and it'll pull down even further. But we'll go ahead and let this guy run. We're gonna go ahead and hit start stop one more time. It'll pull down again. I wouldn't be the least bit surprised if this system has refrigerant leaks. We're replacing it because the equipment's all worn out. So at this point, I'm gonna go ahead and hit stop because we're good. We're gonna turn the knob to purge, and what it's gonna do is it's actually gonna rid the machine of as much refrigerant as possible. Hit the start stop button again. Again, paying attention to the weight, we've only recovered 6 pounds, 7 ounces. Once the machine shuts off, then we'll be good to go. All right, it is all done. It's purged everything out of the machine. Now, there's always gonna be a little leftover trapped refrigerant. We're gonna go ahead and turn this guy off right here. And we're gonna go ahead and unhook all of our stuff and start with our repairs. We're replacing the condensing unit. We've got the old one out now. We're just kind of pre-dry fitting this one. We haven't done any piping yet. We got guys downstairs hanging the coil, getting that ready. I'm just working on electrical because they were using the old disconnect as a junction box for the freezer. So I had to redo a bunch of stuff. We're running the conduit for this one over here. We have to leave room for the walk-in freezer. We're just doing the walk-in cooler today. Disconnect switch, and then we're going to come out the bottom. So we're moving along. All right, this system is a Intelligent, and the unit comes pre-installed with a defrost clock and time delay, and the Intelligent won't work with that stuff. So I ended up ripping out the little junction board and ended up rewiring this the way that it needs to be. So line 1 power jumps over to the coil direct. This is a 208 volt contactor coil. Line 2 runs into the low pressure control, out of the low pressure control, into the high pressure control, out of the high pressure control, into the discharge line thermostat, out of the discharge line thermostat, back to the contactor coil right here. So the contactor coil, there's no electrical communication to downstairs. The contactor coil is turned on and off via the low pressure, the high pressure, and it's a pump down system. So I'm gonna zip tie it all back up and rewire it nice and neat. Kind of scary because I pulled the Schraders out and there's no pressure in the system. Oh, wait, you know what? No, look at, they got these things in backwards. Yeah, this is a little different. Usually these are on this side, so I don't think there's gonna be pressure because I think these are reading this side right there. That's interesting that they did it that way. That's better. Scared me for a minute. Well, I guess that's kind of cool the way that they did that, because then you can vacuum down the line set after you braze it in and then do all your stuff. Right? Got the new coil down here. We're getting ready to pipe it in. We had to turn the coil because it used to face here. This is the one that was all iced up. We had to turn the coil because of this new Intelligent box. So now we got a straight shot into the drain going down the wall right there. And then we're working on piping right now. At this stage, I'm doing a pressure test on the system, and I'm using the pressure tightness test in the field piece manifold. So we've got it pressurized to about 100 PSI. We're gonna let it run for a few minutes. And so long as that happens, we're gonna get the evacuation going.
we are going to start our evacuation, and it's important that we're going to start with the gas ballast open. Okay, you notice the red light turns off and the red light turns on. That means the gas ballast is open. What that's going to do is that's going to let the pump pull the air out of the system without running it through the oil. You're going to save the oil, get a little bit more life out of the oil. I will typically do that until my pump level or my micron level gets down to about 1,000 or 1,500 is my choice. Once I see it get below that, then we'll go ahead and close the ballast. The longer you can do it, the more you're going to save the oil essentially. So at this point, this one has a soft ramp too. We're ready to start it up. On startup, I'm going to go ahead and pull from both sides, and then I may end up closing off the liquid line and getting a true vacuum reading just pulling from the suction once I get levels down a little bit. All right, at this point, my micron level is pretty low, but granted it's pulling from both sides, but I feel comfortable enough going and closing the gas ballast. And we're gonna let the system just continue to pull. And I will go ahead and in a few minutes, we'll go ahead and close off the receiver king valve. And then that way we're getting a true evacuation, but we're gonna let it go for a few more minutes. All right, we're gonna do a phase rotation test with the SC640 or 480 meter. And what we're going to do is we're going to test from line 1 to line 2. And it says line 3. Now we're going to leave line 1 on and we're going to put it on line 3 now. And it says line 1, 2, 3. So my phase rotation is correct. That way we know that when I start up this scroll compressor, it's going to be going in the right direction. At this point, my micron gauge is reading about 446 microns, but again, it is pulling from both sides, so it's not the truest vacuum in the world. So what we're going to do is go ahead and close down the king valve. So we're no longer pulling through the king valve. I'm going to put this cap on because these things are never leak free. And it's okay for our micron level to rise a little bit. It's going to, because it just lost suction from that side. So once it stabilizes out, we're going to have a true vacuum reading of the system, because now it's just pulling from the suction line all the way down through the coil back up through the liquid line. Okay, so again, it's going to rise, and that's normal. When it stabilizes out, that'll be a true vacuum reading, and we're going to let it finish the vacuum pulling from just one side. Up in the attic, we made it a real clean, simple install, so the line set hasn't been sealed yet, but it comes straight down right into the coil, so it's not running on the bottom. That's the foam for the old holes. We ended up doing some electrical stuff, moving electrical lines and everything. Looks clean up here. Evaporator looks good. We're still pulling the evacuation, so it's not running yet. I learned this the hard way. They come with the electronic expansion valve in the mid position, so if you turn power, it closes, and then you have to wait for it to turn on. So if you never apply power, you could do a pressure test, you can purge with nitrogen, and you can pull an evacuation. So we haven't turned on power yet, but the coil's installed. We've spray foamed some stuff. We'll cut all that out. We reinstalled this light that we had to remove. We've still got a foam around that hole. This light was where this coil was. So we've still got a little bit of work here to do. We haven't hooked up electricity. We'll pull the manual down, but it's looking good so far. Occasionally while doing a vacuum, you may run into a problem where all of a sudden the vacuum stalls, and it may be because of contaminated oil. It happens quite often. The field piece pump has got an on-the-fly oil change system. So essentially what we're going to do is right over on this side of the pump, we've got an oil container. I usually keep an extra one fully loaded with oil. Okay, we're going to simply just open up this, pull the top, the oil in there. As soon as it's done, you have time. So as soon as it's done, we're basically going to close this valve off. Right now, pour in the oil. We're not messing with our vacuum at all. It's perfect. There we go. Easy, easy oil change, nice and clean. Put the cap back on, let it keep running. We never lost our vacuum, nice and good. While you're doing your evacuation, you notice that my micron gauge is at about 401 microns. That is a true reading. It's pulling all the way through the other side, but I haven't done a decay test. It's always important to try to have the crankcase heater on, and it is, it's nice and warm. But what that does is that helps to heat up the oil to get any trapped gases, non-condensables that are in the system. So in this case, it would be nitrogen, because the system was pressure charged with dry nitrogen. So it's still kind of trapped under the oil. So what you can also do is just kind of agitate the compressor and just agitate it a little bit, and then watch the micron gauge, and you'll see it'll start to climb in a minute. Here he goes. We're climbing now. It's not much, but every little bit helps because that's just trapped gases that's going to mess with your decay test. From experience, when doing a startup on these Heatcraft units, you always want to open up this discharge valve, service valve right here, and make sure that it's backed all the way out. I found them pushed like almost closed from the factory. This one is, it's pulled all the way back out. So that's good. It's just a standard service valve. That's there for changing the compressor. You can isolate just the compressor and not have to recover the charge from the whole system if you ever wanted to change it, because you can isolate the suction one right there, the discharge one right there, and then just recover the little bit of gas out. One of the very last things I want to do is the mastic on the roof jack. So I'm not particular about this. I usually do right around the hole, do a little dam. You guys see that? That way if the water ever got through, and then I trace it out with a marker. You can see my marker mark, and put mastic all underneath there, so that way I can push this down, and when I push it down I want to see it goober out just like that. That way we get a nice good seal, and then I'm going to put some Tech screws just to hold it in place, and then we'll go over the seams and then also seal up this up in here. Try not to go too crazy, and then of course I'm going to tell them to get a roofer out. Most of the time they don't, but I'll just tell them to get a roofer out just to double check. They may want to do something different. This is all that I have the capability of doing for now. But yeah, just keep mushing that stuff out, get a nice good tight seal, put some Tech screws to hold it, and then we'll seal around it and then seal up that penetration. All right, we're getting ready to charge this right now. What I did was I purged all the way to this hose, purged all the way to this hose. Now remember, this vacuum can take positive pressure. So now that we're purged, I'm gonna go ahead and zero out the scale. Let me actually turn it on. Okay, turn the scale on. And notice it reads weight. We're going to zero it out. Oh, sorry, zero weight is actually what we need to do. Okay, scaled, zeroed out. Now, I happen to know that the maximum charge of 448A in this system is 14 pounds, and that's the perfect amount that the factory recommends. So we're going to charge to 14 pounds on this guy. We're going to charge into the high side. So what we're going to do is open up this king valve. It's open, and we're going to go ahead and charge through the high side. All right, and the cool thing is that the scale's weight is displayed on the gauges. I wrote all over the unit what refrigerant, how much gas. I've done enough of these units that I know it takes exactly 14 pounds, and that's for the full winter charge. Wrote everything on there. Currently right now we're at about 5 amps, just under 5 amps current draw, not a problem. I checked the rotation of the compressor. Everything's looking good, so we're gonna watch this guy come down in temp for a bit. It's still not in the most opportune place to be able to access the display, but it's better than nothing. We're nice and good, sealed up all of our holes. We'll be back to cut the foam and stuff like that. We're gonna be working on the walk-in freezer soon, so, but at least we can get up here and be able to access everything. It's good. Their next thing is gonna have to be to replace the doors. The doors are messed up, and then this one is messed up too.
Okay. Installations, again, are difficult for me to film. Again, like I said, because they have all my employees there, and I don't want to film my employees just for a lot of different reasons. So, but there was some pretty cool stuff in here. I like to share the little tips and the ways that I do things. Like, for instance, putting down the roof jack when I was sealing up the penetration. Of course, I always tell the customer to call a roofer out and have them make sure everything's good. You know, I can only do so much when I'm sealing up a penetration. But in this situation, you know, that little method that I use of sealing on the inside, I used the Henry's 208R, I believe is what I use, or 209R roof mastic. But I use the stuff that comes in like a silicone caulking gun, so that way I can be very precise and it just doesn't go crazy. In hindsight, I don't think I got footage of it, but I ended up just, my craziness got the best of me, and when I was all done with it, it was not pretty anymore. There was mastic everywhere. It's just, mastic has always been a difficult thing for me. But I will be going back to this job, and I'll show you guys what happened with the mastic on another video. But anyways, I like to show those little bits of things, you know, how I push down the roof jack and kind of smudge all the crap out and put some Tech screws in there to hold it in place and then seal it up. That's just my method, and it's worked really well for me, okay? And other little tips, you know, we try, and it doesn't always work out perfect, but we try, like I did in this video, to make sure there was no braze joints in the attic, right? Because I think about the next guy. I think about myself and or the next guy having to go do a leak search on this thing. And guess what? If I can prevent putting braze joints in the attic, attic, then that's one less potential leak spot that I have to go climbing through the attic to find. So in this situation, I use the hydraulic tubing bender, or actually not hydraulic, I use the ratcheting tubing bender, and I bent everything. So there's only a braze connection on the roof and down at the evaporator. That's it. There's nothing in the attic. So it's little things like that that I think is going to help you in the future if you guys can try it. It's not always perfect, okay? This is a situation where my condensing unit was easy enough to make it just one bended line set, and it was easy, okay? Other things that we like to do to try to make things easier is, and I kind of talked about it, the evacuation. You know, spending time with your evacuation and understanding how an evacuation works. Also, understanding it's very hard to pull a perfect vacuum, guys. I can't stress this one enough, okay? I am not perfect. I do not always pull a perfect vacuum. I do not always achieve a perfect decay test, okay? It's almost impossible to get a perfect vacuum. Now, on new installations like this one, it's a little bit easier because you're starting fresh. You know, yeah, you've got some contaminants in the oil, potentially some non-condensables, the nitrogen, dry charge, and all that stuff, you know, but it's a lot easier on new installations. But on retrofit systems or systems where you're just doing a repair, it's almost impossible to pull a perfect vacuum. And we should talk about that in another video too, but there's also some arguments to say that a perfect vacuum, or what you think to be a perfect vacuum on a system that you're making a repair on, is actually not completely necessary, because a lot of times if you have a system that has had refrigerant in it, there's still going to be refrigerant boiling out of the oil for a very long time, you know, so arguably you're really not putting air into the system if there's refrigerant boiling out of the oil, you know, but that's a whole nother thing. We'll make a video about that and I'll show that one time and kind of talk about it a little bit more, but anyways, I'm rambling at this point. I really appreciate you guys taking the time to watch these videos. Do me a favor, please consider subscribing to the YouTube channel. If you're interested in any of the HVACR videos merch, go to my website, hvacrvideos.com. Merchandise is available. We are sold out of a lot of stuff right now, and I did place another huge order, so another couple hundred shirts are coming in, and there's like 100-something hats coming in, so we'll be restocked hopefully soon. So if anything's out of stock, just stay tuned. It'll come up soon. Yeah, if you guys are interested in considering purchasing any tools, if you're in the market for any tools, check out TrueTechTools.com. Okay, I have an affiliate link thing set up with them. If you guys like their pricing, I can attest to their customer service, and they have high quality tools and everything. If you guys like their pricing, do your research. Okay, don't just trust some idiot on YouTube. Do your research. If you like what they have, do me a favor. If you're going to purchase something, use my offer code BIGPICTURE, one word, okay? And I get a small affiliate commission. You get 8% off your order. Win-win, right? You save a couple bucks. I get a couple bucks, and it kind of helps to support the channel, okay? I really, really appreciate you guys taking the time to watch this, and we will catch you guys on the next one.